So a biotech stock just skyrocketed 38% practically overnight. And for once, the hype actually seems to map the science.
Yeah, it really does.
Right. A new once-daily pill has literally doubled survival times for pancreatic cancer, which, is one of the deadliest and most notoriously difficult diagnoses out there.
That's incredible news.
It is. So welcome to the deep dive. Today, we're taking a stack of clinical trial data, medical news releases, and even some patient support Reddit threads to figure out how scientists finally cracked this.
Oh, and a quick note before we jump in. We are definitely not doctors.
No, absolutely not.
Right, this is purely an informational look at the sources for you guys. Always consult your actual medical professional.
Exactly. But looking at the data we have here, the shift in outcomes is just massive. To really grasp the scale of this breakthrough, you have to look at the baseline first.
Which is pretty grim, right?
Very. The 5-year survival rate for advanced pancreatic cancer has been stuck at a grim 3% for a long time. It's essentially an absolute biological fortress. And that's mostly because it's usually found so late, right? Like, by the time someone actually feels symptoms, the disease is already advanced.
Yeah, exactly. It's advanced, and standard treatments just kind of bounce off it.
Right. The sources mention intravenous chemotherapy, drugs like fluorosil or gemcitabine, but those are brutal on the body, and the tumors eventually just mutate and ignore them anyway.
They do. They adapt very quickly.
I mean, it's like trying to put out a grease fire with a water pistol. Why has this specific cancer historically been such a fortress?
Well, the tumors adapt, yes.
Yeah.
But the phase 3 trial data for this new drug, which is called Duraxonrib, shows it bypassed that resistance entirely.
Oh, wow.
Yeah. Patients taking this drug survive an average of 13.2 months, and that is compared to just 6.7 months on standard 5E chemotherapy.
Wait, really? It doubled it?
It did. It essentially froze the disease's progression. And remember, this is a once-daily pill, not an IV drip.
Okay, let's unpack this because I really need to push back on the science here. It sounds completely counterintuitive to me. Well, if pumping someone full of highly toxic, really aggressive IV chemotherapy completely fails to breach the bunker, how does a simple pill taken once a day suddenly bypass all those defenses?
Because it's not about brute force. It's really about picking the lock.
Okay, picking the lock. I like that.
Yeah. So over 90% of pancreatic cancers rely on a specific mutated protein called RAS. Just RAS.
So we're avoiding the alphabet soup of acronyms today.
Definitely. You could just think of RAS as a cellular engine. Normally it idles, and it only revs up when the cell actually needs to grow.
Like during normal cell division.
Right. But the mutation jams the throttle wide open. The cancer is just constantly driven to multiply.
Okay, but if we've known about this jammed throttle, why hasn't someone just built a drug to block it before? I mean, the literature literally called this protein undruggable.
It comes down to its physical shape. The RAS protein is incredibly smooth.
Smooth?
Yeah, there are basically no deep pockets or grooves for a synthetic drug molecule to anchor into.
Oh, I see.
It's like a molecular greased bowling ball. If a drug can't latch on, it obviously can't shut the engine down.
Right. So if Duraxonrib can't grab the greased bowling ball directly, how on earth is it shutting off the signal?
Through a really fascinating piece of chemical engineering. Duraxonrib doesn't even try to attack RAS alone.
Wait, it brings a friend?
Basically, yeah. It enters the cell and binds to a specific helper protein that your body already naturally produces.
Oh, fascinating.
And when the drug and this helper protein fuse together, they create a completely new, bulky shape.
Oh, I see. It's altering the key.
Exactly. It creates a complex that perfectly matches a tiny, shallow groove on the RAS protein, a groove that neither of them could latch onto individually.
That is so clever.
It is. They lock in together, physically block the signal, and cut the throttle.
So it's like instead of trying to fight the bouncer at the front door, the drug sneaks in, grabs a bartender, and together they have the clearance to walk into the back room and just cut the power to the music.
That is a perfect analogy. The tumor is suddenly starved of its primary growth signal.
Wow.
And because it specifically targets that underlying RAS mutation, it's not strictly just a pancreatic cancer treatment either.
Wait, so this approach is likely to work elsewhere?
Yes, trials are actually already underway for other RAS-driven diseases, like specific types of lung and colorectal cancers.
Which completely changes the entire landscape.
It really does.
I mean, you read through that patient support Reddit thread we pulled and you see what this actually means on the ground. Families are literally calling it the biggest breakthrough in 30 years.
Yeah, the human element is staggering. Clinic workers are posting about how the mood in their wards has completely shifted.
Because they're getting time.
Exactly. Time where the cancer isn't worsening.
Yeah.
And crucially, time without the debilitating nausea and fatigue of standard study chemo, because it's just a daily pill.
Right. During the trial period, for every 10 patients who would have died on standard chemo, 6 were still alive on this new drug.
The bunker finally has a breach.
It does. Which leaves you with this final thought to ponder. If scientists have finally figured out the molecular trick to pick the lock on the undruggable RAS protein, what other impossible biological mysteries might just be one helper protein away from being solved?